We're doing 2 days of applications, today and Monday, and I've said this before, then Tuesday's review, Wednesday's test. 2 days of applications, and they're basically the same. We might do something slightly different on Monday just to break up the period a little bit, but basically it'll be more practice of applications. We'll hand out the review, probably even post the review before the weekend. And there's nothing really all that different about applications, I would say, except that it's always asking a question, so you got to make sure you answer the question, and sometimes those questions can be asked in slightly strange ways, right? And it will often ask, a lot of these questions will talk about average rate of change and instantaneous rate of change, and maybe having kind of comparing those, whether you're actually comparing them mathematically or just sort of in your head. Whoa. So if you look up here at the board, then this is going to be a problem. The other thing that, well, you can look at the question, I was going to go turn the lights on. That's not going to work. If you look at the question, the numbers in applications are often also tricky, right? You see those decimals in there. So sometimes the algebra works out a little bit differently because the numbers are a little bit messed up. I'm going to say start the first couple of steps. So the first couple of steps, the question says, the movement of a certain glacier can be given by the following formula, where D is the distance in meters. Again, looking at units is always really important. Okay. So the distance in meters that a stake is traveling, and relative to a fixed position, blah, 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 just movement, right? And then T days, so time is measured in days, that's really important. Find the rate at which the glacier is moving after 20 days. Is this average rate of change, or is this instantaneous rate of change, Jason? It's instantaneous because it's at a particular time that it's moving instantly. And again, if you take calculus, this is something that we do a ton of, and it's really important that you understand that it's happening at an instant, and what is that instant, and what exactly does that mean. But these questions are fairly straightforward for us. So at 20 days, so you're going to find out the value of the function at 20 days, and then you're just going to use the slope of the tangent formula that we've been using all along. I'm just going to go check and see. All right, let's do this. So hopefully most of you are kind of ahead of me here. We've got T equals 20. We already said it's instantaneous rate of change, and the 20 days is our T, and then D at 20. And again, it's just a little bit wonky. You don't have to show this step like we don't usually, but just make sure you substitute properly. Sometimes that's enough that the function we're given or the equation that we're given in a word problem is unfamiliar enough because of decimals, or it's just a little bit wonkier that we mess up in that step. And remember, I said this before, sometimes people either evaluate that wrong or forget to do it, and then the whole rest of the process doesn't work. The limit as T approaches 20, right? For D of T minus D of 20 over T minus 20. So that's going to be our formula. Skip the f at x minus f at a part. And function notation would require us to use the D's and T's instead of the f's and x's, right? Because that's how that was given to us. So for communication, that's typically how we would do it. So then, what happens here? D at t is 0.01 t squared plus 0.5 t minus 14 over t minus 20. There are two things that you can do here. Well, there's sort of more than two things, but I would recommend two different ways of doing it. We know that the t minus 20 has to be a factor that comes out. So on top, I have to get t minus 20 as one of my factors. But I have to figure out what the other factor is, because that's what's going to be left over. And if I made a mistake above this, I have to be careful making this assumption, and I just have to really check my work. Okay? So we could do synthetic division. We could take this, it's just a quadratic. We don't usually use synthetic division with quadratics, or long division if you prefer that, right? But I could do t minus 20 divided into this quadratic using synthetic division to get what's left, okay? And what's left would be something t plus or minus something. That's like a surefire way of working out what's left. But also, I can use a little sort of trick, or I mean, it's just a quadratic, so we know those pretty well. And I can say, well, 20 times something gives me 14. So what does that something have to be? How do I figure that out? Divide 20 by 14, or 14 by 20? Well, which one is it? Think to convince yourself, because this is something that even if we get the right answer now, in the middle of a test, you're going to be like, oh, shoot, which one is it? 14 by 20, and you can always just go back and double check. So 14 divided by 20 is 0.7, and it's a negative times a positive. That has to give me a negative, and I can convince myself that this is correct, because when I expand, it's going to be 20 times 0.7 has to give me 14. So check that on your calculator. Make sure that you're happy with that answer, and you should be good. Okay? And then I'm going to figure out what the other part is. Well, actually, it's not too bad to figure out, because it's has to multiply to that. So this coefficient typically is just going to be 1t. So my coefficient here is going to be the 0.01 t, or whatever the a value, that leading a value is of that expression, right? If this wasn't a quadratic, it was something bigger, maybe then in that case you do use synthetic division. Often they're quadratics. And then here's the check that I would do. So everybody maybe do this on your calculator now. I would do this times this plus this times this, and make sure I get that middle term. And if you do, then you're good. So in this case, it would be negative, whoop, no, don't want that. Clear. Negative 20 times 0.01 plus 0.7 times 1, so that's 0.7 gives me 0.5. Okay, so I got my middle term. Does that make sense? And so again, this had to work out this way because of that. Of 0.01 t plus 0.7, and then I can sub 20 in. And you can probably do that in your head, or if you want to use a calculator, you should get 0.9. Now interpret this answer. What does this mean? Okay, so the question was about a glacier moving. Therefore, is moving 0.9. Oh, always happens once. 0.9 meters per day after 20 days. If it was even a second more than that, my answer would be slightly different. If it's changing speeds, it's accelerating or decelerating or something like that, at any other time, it'll be slightly different. But at exactly 20 days from whenever this process started, 0.9 meters per second. Any questions about that? All right, one more. The profit in dollars of a manufacturer selling digital phones is given by this quadratic function, where X is the number of phones sold and P is obviously profit. So we've got two things to do here. Find the average rate of change between 100 and 150, so from selling 100 phones to selling 150 phones, and find the instantaneous rate of change when 3,000 phones are sold. Just want to talk about a couple of things here, because a question like this you can solve. If you're good at this math, it's just a quadratic. You could power through the math without really thinking about what's even happening here. But if I just sketch this as a quadratic, it has a y-intercept of negative 3,000. And then it opens downwards because it's got a negative a value. And I don't know, in fact, do I know for sure that it'll cross the x-axis and go above and stuff? Maybe not just by inspection, but I've graphed this before, so I know that it does go into positive profits. But like, what does this graph mean? You'll notice a lot of questions talk about profit on the worksheet, and or like if you take anything business, obviously you talk about this all the time, and it's something that we talk about in math class. And so what does that mean? It means if I sell 0 phones, I'm down $3,000, and I'm not going to get profit. I'm not going to make any profit until I sell this many phones, whatever that is. Well, we know how to solve for that. So I could find the value where I start making profit, and it means that up to some point, this vertex, that's where my maximum profit will occur. And after that, I'm actually losing money every phone that I sell. Why would that happen? I don't know. In math class, this is always the thing. There are sort of reasons why that would happen. With big companies, it's not typical. But with a small company, maybe all of a sudden you get overhead or something that starts to outweigh your profits. I don't know, your costs. So that's what it looks like, right? So we're finding the average rate of change. Now this one says average rate of change, but if it just said find the rate of change between the values of 100 and 150, you need to know that it's asking you for average. If it gives you two values and says between these two values, it means the average rate of change. So every question may not say find the average rate of change, you know what I mean? So if it gives you two values and says find the rate of change between them, that's average. If it says find the rate of change at 3,000 phones sold, that's instantaneous. Pretty obvious, I think. It'll be pretty obvious to you what you're being asked to find. All right, so let's go ahead and do A. So again, we need to find the value of the function at both of these. And negative 0.05 times 150 squared plus 200 times 150 minus 3,000. And P at 100. Oh, sorry, there is a mistake on the sheet, and I forgot to mention that, but it should be 30,000. So we're going to add an extra zero in there. Just do that now. Not to the 3,000 phones sold, there's a mistake, a misprint in the function. So it should be 30,000. Try that on your calculator. Some people can do 150, some people can do 100. We'll share our answers. So negative 1,125 is what I get here. Has anybody done the other one? Yeah. Yeah, negative, right? Yeah. Good. 10,500 for the other one. And so then the average rate of change equals P at 150 minus P at 100 over 150 minus 100, which is negative 1125 minus a negative means plus 10,500 over 50. What does that work out to? Does anybody have that? Yep. Divided by 50. Should be 50. How easy is that to fix? 9,000 parts sounded right to me. Does anybody else have that answer? Go ahead. That sounds right. And that's positive? Yeah, because that's money, right? We don't need units there because we're going to do an answer. Find the average rate of change. So from 100 to 150, the average rate of change was positive. What the total profit was still negative for both of those. But the average profit increase was positive. So it's kind of a strange, like what is that? A profit of 187.50. That's the average rate of change of profit. It's not profit itself. It's the rate of change of profit. A strange thing to think about, worth thinking about. Okay. And then B, find the instantaneous rate of change when 3,000 phones are sold. So again, we want to figure out what that is. And then we're just going to use our slope of the tangent formula, which in this case is going to be P at X minus P at 3,000 over X minus 3,000. Okay, so I'm going to let you try this one. Megan pointed out I'm missing my limit statement. Thank you. Limit as X approaches 3,000. There we go. What'd you get for the value of the function at 3,000? Jason? 1,020,000? Or 200,000? You got 120,000? Yeah, I think that's right. Decimal off by one spot, maybe. Yeah. Now that looks weird. Okay, so go ahead and finish the rest of that to the best of your ability, and I'll put the answer up after.